Question 11. Feel free to pause and solve. You might notice that the numerator and the denominator adds up to a plus b plus c plus d for each of the four fractions. So if we add 1 to each fraction, then on the right hand side we will have 43 over 10, and on the left hand side all of the numerators will be equal to a plus b plus c plus d, which is equal to 8. Now at this point the expression looks very similar to the value we want to find, but with 8 instead of 80, so we can just multiply by 10 and get that the answer is 43. Question 12. Feel free to pause and solve. Because the magnitude of the product is the product of the magnitude, we want to express Zn plus 1 minus Zn as a product. Since Zn plus 1 is negative 3 over 2 plus root 3 over 2I times Zn, Zn plus 1 minus Zn is then equal to negative 3 over 2 plus root 3 over 2I minus 1 times Zn. Since Zn is itself a product, we can then find the magnitude of each individual part and find that the whole expression is equal to 7 times 3 to the power of n, and we want this to be more than 7,000, so we can easily solve this and find that n is more than or equal to 7. Therefore, the answer is 7. Question 13. Feel free to pause and solve. Now the question tells you an equation in terms of some squares and BC, which should remind you of the cosine rule. So trying that out, we get a squared equals b squared plus c squared minus 2bc cosine a. And since angle A is known, we can simplify this further. And we can compare this to a squared equals b squared minus bc, which you can get from the question. And indeed, it's very similar, and we can cancel and simplify it to get root 3 minus 1 bc is c squared. Since c is obviously not 0, we can then find b in terms of c. And note here that b is more than c, so angle c has to be acute. Now we can also find a in terms of c, and now we can use sine rule to find sine c, since we know a in terms of c and we know angle a. We find that sine c is 1 over root 2, and therefore angle c is 45 degrees, since it has to be acute. Therefore the answer is 45. Question 14. Feel free to pause and solve. Usually, when we have a sum of factorials, we try to take modulo something so that most of the terms will cancel out. In this case, mod 2, 3, and 4 turn out to not work, so next we try mod 5. If we take mod 5, everything past 5 factorial will be congruent to 0 mod 5. So for n more than or equal to 5, the left hand side will just be 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial, which is congruent to 3 mod 5. But it is easy to see that squares mod 5 can only be 0, 1, or 4, so this is a contradiction, and n is less than 5. And now we can check the few cases that we have and find that the largest possible value of n is 3. So the answer is 3. Question 15. Feel free to pause and solve. We factorize 323 into 17 times 19, so that instead of having to deal with mod 323, we only have to deal with mod 17 and mod 19, which is more manageable. In this case, a bunch of the terms cancel out, and both equations actually end up having the same solution, which is that n is even. Because if n is odd, then the left hand side and the right hand side will be negative of each other, which can only be equal if it's 0, which is impossible, obviously. Therefore, we just have to count the even numbers, and there are 1008 of them, so the answer is 1008. Question 16. Feel free to pause and solve. If you try this with smaller even values, then you'll find that no matter what you do, one of the types of fruits will be split evenly between the two boxes. So we'll try and show that this is always the case. Let A, B, and C be the number of apples, oranges, and pears in a certain box. Now we'll take modulo 337, since 337 is half of 674. Then we'll get ABC is congruent to negative ABC, and since 337 is odd, ABC is congruent to 0 mod 337. Since the question says both boxes contain three types of fruits, A, B, and C cannot be 0 or 674, so one of them has to be 337. Then you can do some simple algebra to find that the other two variables have to add up to 674. We can also easily verify that these solutions always work. Now, since A, B, and C cannot be 0 or 674, there are 673 solutions for when A is 337, and similarly for when B or C is 337. You would think that this makes 2019 ways, but note that we are triple counting when all of A, B, and C are 337. So we have to subtract 2 and we find that the total is 2017 ways instead, so the answer is 2017. Question 17. Feel free to pause and solve. Now you could try to solve this as a quadratic in x or y, but that would be extremely complicated and the discriminant would be quite complex. So we try and simplify it first. So we move one y to the right hand side so that the left hand side is very neatly factorizable. Then we can express 2017x plus 2019y as 2017x plus y plus 2y. And then now we can multiply everything by 2017 so that we'll end up with a quadratic in 2017 x plus y that is much simpler than the original quadratic. So let m be 2017 x plus y. Then we can solve for m and the discriminant is y squared plus 2017 y. Since m is obviously an integer, y squared plus 2017 y must be a square number. Let's say y and y plus 2017 are co-prime. Then they have to be either both squares or both negative of squares. So the difference between two squares would be 2017. So for some a more than b, a minus b times a plus b is 2017. Since 2017 is prime, we only have a minus b is 1 or 2017, so a has to be 1009 and b is 1008. So the bigger square is 1009 squared and the smaller one is 1008 squared. Or the bigger square could be negative 1008 squared and the smaller one could be negative 1009 squared. Since y is the smaller one, that means that y is 1008 squared or negative 1009 squared. However, if y isn't coprime with y plus 2017, then it will also not be coprime with their difference, which is 2017, which is a prime. So y has to be a multiple of 2017. So we can divide everything by 2017 squared and we'll get n times n plus 1 being a square, where n is y over 2017. But n and n plus 1 have to be coprime, so they are both plus or minus a square. So n is obviously either 0 or negative 1, and so y is either 0 or negative 2017. So now that we found all possible values of y, we can find all possible values of m, and therefore find all possible value of x, and we can add them together to get that the answer is 4036. Question 18. Feel free to pause and solve. We can complete the square, which makes the square roots look like the distance between 2 points. So fx can be expressed as the distance from 5, 17 to x0 to negative 10, negative 15. Note that we use negative 15 instead of positive 15 so that x0 can lie on the line between the 2 points. This clearly minimizes the total distance, so we just have to calculate the distance between 5, 17 to negative 10, negative 15, which can be easily done, and we find that the answer is 35. Now I'll pass the time on to Rafael, who will be explaining the last 7 questions.